Okay, so let's start. So Happy New Year, everyone. So this is the first meeting of the AI for Good in New York of 2023. So we have the pleasure to have today Richard, Will, and Emily from Uncharted. Uncharted is a company based in Canada, and they are focusing on. I mean, they do a lot of things using AI maps, and they did a lot of interesting projects, and they're going to tell us about what they do. So why don't you present what you do, and then we go into the presentation. Maybe Richard, you can.
Sure. I can do a quick introduction to Uncharted, and we can start with who are the people on the call. So myself, hello, I am Richard Brath with Uncharted Software. I am a partner here. We're set up a private company. We're set up as a partnership. I'm one of the partners. I've been working in the field of visualization and analytics for many years. So for example, books on things like visualization with text or graph analysis are areas that I've written on over the last few years. So that's myself, and then Emily.
Hi, everyone. I'm Emily White. I'm the Director of Global Resilience Initiatives at Uncharted, basically looking at how systems from justice to health to obviously technology can affect vulnerable groups, and also how they can, when strengthened, strengthen vulnerable groups.
Hi, everyone. I'm Will. My role at Uncharted is really trying to connect customer problems to the tech and make sure that we can deliver value. I've spent a long time in the renewable energy world, trying to solve things from that direction, and I'm glad to be back in the tech world looking at different problems, different hard problems.
Okay, very good. So let me tell you a little bit more about Uncharted. You probably don't know us. We are Toronto headquartered, but in fact, many of our people, like many companies these days, work in various different locations. So Will is on the east coast of Canada, Emily is in Ohio. And you probably have seen our work before. So we end up doing a lot of work in New York City and also US East Coast. And our core capabilities are really focused on visual analytics, explainable AI, and human-in-the-loop systems. And so, for example, one of those things is the NASDAQ tower in Times Square, New York City, where we have stock market visualization showing, the live data, what's going on there. Another example in the center there is World Cup data showing connections between cities based on social media responses and chatter between different locations. And you can zoom interactively and explore all of these things in detail. So what the topics are in different cities or which cities connect to which cities becomes very apparent. And then the third example is Major League Baseball, where we've created analytical solutions on top of pitching and hitting data and the corresponding video that is associated with that for the coaches to explore and interactively plan their games. And so those are just a couple of quick commercial examples. Beyond those corporate examples, here are some example applications in the domain of AI for good. First, on the top right there, this is an application around critical minerals. We recently won an AI competition sponsored by DARPA to help find critical minerals. And the basic idea there is that old maps may contain information about minerals, but those maps are just literally bitmaps, and we use AI approaches to figure out where those maps actually are in the world and use those AI techniques to figure out what minerals are on those maps. Second example on the bottom left there is with regards to food security. This is an application where we take data that is reports about insect infestations, And we compare those conditions where those reports have happened against satellite imagery and the 12 bands multispectral data that you have there, to be able to find other areas that have similar signatures that would then be indications of potential areas of risk of infestation. And then bottom right, see, that's an example where we're actually working with COVID data. One of the challenges there is there's a massive amount of publications, scientific research publications. And when something like COVID happens, it's updating very frequently. And each of these research papers is discussing different aspects about COVID, different biological mechanisms, different connections and associations between these different systems. And how do you map that out? How do you figure out what's connected to what, particularly if you're a researcher, to find adjacencies that are going to be helpful to inform you to what you're going to do? And we use NLP and AI to extract the topics, the groups, the connections, and then create an interface on top of that to be able to explore and drill down and find new approaches that might help in creating medicines or appropriate responses for that. And then the fourth example that we're going to talk about is TellFinder. And TellFinder is our solution for anti-human trafficking. TellFinder is probably the most mature, one of the biggest, longest projects that we've worked on in this area. And Emily is going to tell you the story of TellFinder.
Thanks, Richard. Hi, everybody. Like I said, Emily Wyatt. My background is both in counter-human trafficking and sort of as a technologist. So I've been working counter-human trafficking since 2003, both in South and Southeast Asia, and most recently domestically and in the online sphere. Next slide, Richard. So before I talk about our solution, or TellFinder, the software for counter-human trafficking, I want to talk a little bit about how human trafficking is a data problem, and sort of like where it all starts. Next slide. So just to give you all a quick primer, commercial sex is illegal in the United States because, actually, except for 2 US counties, but because it's illegal and an informal sort of gray economy, it lacks what other sort of industries would have, which is robust regulatory enforcements and protections. So the illicit economy is at high risk for exploitation. So when a lot of us think of the commercial sex industry, we think probably of the traditional visual of someone selling sex on a street corner. Next slide. But that's really not how it works as much anymore. All of the advertisements for commercial sex have moved online. There are hundreds of websites advertising commercial sex, and the amount of data related to them, all these advertisements, the review boards, the chat forums, it's a massive amount of data, at least 150,000 online ads for sex services every day around the globe, and it grows all the time. This data is transient and temporary. It lives in the deep web. So these ads go up and come down. And because commercial sex is illegal in a lot of places, the advertisers, individuals who post these ads, don't want to get caught by law enforcement who are constantly scanning these advertisements. So the ads go up and they come down, and they go up and come down in order to evade law enforcement. Next slide. Of course, for law enforcement, this creates a huge problem, right? Because it's a huge data set and it's so transient. So identifying ads of interest and how they may be connected to each other takes a very long time. So if you have an alleged perpetrator that is putting up ads over locations, let's say New York and Philadelphia and DC, and over time, maybe using the same number in some ads or different phone numbers or email addresses in others, unless you're an investigator that's glued to a computer searching 24/7, you're not going to see that coordinated activity over time and space. Next slide. So TellFinder is a software platform for law enforcement investigators that uses advanced technology to identify and collect this deep web content and discover hidden connections in data. Next slide. So what does that actually mean? What is TellFinder? What is it giving investigators access to? TellFinder is to the deep web what Google is to the internet. So it's a search engine basically for the online marketplace for commercial sex. It works by giving investigators access to what stands right now at over 300 million internet ads for sex. Many obviously long since taken down from the web. Our data set actually goes back to about 2012. And again, it's global across the world. So users can use it to search things like you would an online shopping platform. There are filters and search terms. So you can search phone numbers of someone that you suspect is advertising people for sex, or emails, or even images. Filter results by location and time. If you're an investigator in a particular jurisdiction and you only want to look inside your jurisdiction, you can do that as well. The goal with this is to not just generally understand commercial sex as it's represented online, though that's helpful, and there are a number of tools that kind of at the very best identify trends and risk, or at the very worst just help us to admire the problem. TellFinder was purpose-built in direct collaboration with law enforcement, actually law enforcement there in Manhattan, for investigators to generate leads and produce actionable intelligence. Next slide. So how did TellFinder come to be? Well, it was created as part of the Defense Advanced Research Projects Agency, or DARPA, DARPA's MEMEX program. This was a program that started in 2014, was 3 years, $60 million in investment by the federal government across 17 teams, including universities, businesses. Uncharted obviously was one, and working in partnership not only with law enforcement here in the United States, but with US allies to kind of understand the footprint of human trafficking online, what global law enforcement investigators were facing as far as this incredibly large data analysis problem, and then what could be done to simplify it. So as I mentioned here, we worked in direct partnership with the District Attorney of New York. They were our core partner throughout this program and tested all of our MVPs and an sort of evolving technology over time, till at the very end of the program, TellFinder was the program that encapsulated all our advances in search, in natural language processing, image matching, you name it, network identification. Next slide. So because the District Attorney of New York investigators were our very dedicated set of investigators, in fact, they were our power users in a group of over 1,200 law enforcement users across the globe, we wanted to see how the introduction of TellFinder actually affected their ability to investigate. Because like I said, huge amounts of data, incredibly manual process. And you can see here, from 2001 on the left, right about till, I think that's 2014, when I started training them on the tool, their investigations actually multiplied from about 10 a year to about 300 a year. So just introducing this tool, helping them have access to persistent data and being able to analyze that data, just was a total game changer in their investigations and operations.
Emily, just to tell the audience, we'll take the questions at the end. There'll be a Q&A session, right? So we don't interrupt the presentation.
Great, thank you. Next slide. So I wanted to highlight a little bit about what the impact of these investigations were. And of course, we have lots of stories from the District Attorney of New York and their various investigations, but I wanted to highlight one global one, which was our work with UK intelligence. We worked very closely with UK intelligence and law enforcement in the UK to kind of understand their use case, what online data looked like in their jurisdiction, varies all over the world. And they told us a particular story as they were using TellFinder, where one of their law enforcement officers arrested a man for a traffic violation. And in his wallet was the ID of a young woman who was not with him at the time. They confiscated that ID, which of course had a picture on it. And this man was suspected of a number of crimes. So one of the things they did with the ID was to take the woman's picture and search that photo in TellFinder. Lo and behold, the woman's photo on her ID matched a photo of her in an advertisement for sex. This unraveled a huge investigation in which they understood this man was pimping women for sex online, and he was actually part of a Romanian trafficking operation. 8 suspects of an organized crime group were later arrested and successfully prosecuted and convicted. Next slide. I also want to talk a little bit about TellFinder's impact on prosecution. So TellFinder is the first, and to my knowledge, only provider of internet data for counter-human trafficking prosecutions. We were able to supply data in a federal trial by the Department of Justice in the Eastern District of North Carolina for a man who was being brought to trial for 5 felony charges, including 3 sex trafficking charges. We provided evidence. We provided expert witness testimony to the US government on behalf of the prosecution, and the defendant was found guilty on all charges. He was sentenced to 3 consecutive life sentences, which in my experience, having done this for over 20 years, is the longest sentence that I've ever heard of. So just having this kind of hard data in these sex trafficking trials can be extremely effective for a number of reasons. One of them, though, for example, is often when you have women who have been victims of sex trafficking, they have been unwillingly addicted to drugs. They're not reliable witnesses because of gaps in their memory and information that they have. This data can really reinforce their testimony of what they do remember and what they do know of their experience. And so bringing that hard data really buttresses the victim's testimony and can lead to a successful prosecution. Next slide. And so here, now that you have an idea of what the application of AI and advanced technology looks like for a social good problem, I want to hand it over to Will so he can kind of unpack that a little bit more.
Yeah, thanks, Emily. So we've just heard about an incredibly impactful use case for advanced technology, and there's some specific AI tech in TellFinder that helps it do what it does, and that sounds great. So what is the problem? And in the tech industry, we often talk about patterns. What patterns can we use to solve problems? And so there is a real pattern of problems for this area. Often when we have new tools, new languages, new things like AI, the tech industry, those of us in it, we get excited and we see a space where we can do some good, where we can impact the world. We want to take our expertise, our passion, and direct it into those spaces. And that's amazing. We need to do that. And often, many of us here have participated, we'll put together a hackathon. We create some shiny new answer machine, and we'll try and solve the whole problem. And what we find is that in the cases of focused social good, areas that really require expertise, like in counter-human trafficking, the analysts, the domain experts that are there, they have a long experience of working in a particular way, solving their problems in a particular way. They don't necessarily trust the technology solutions that we're producing because they don't understand what's going on under the hood. If we take all of the massive amounts of data that TellFinder is looking at and just spit out a report of these people are being trafficked here, it doesn't help. It doesn't solve the problem at all. And there's a bigger problem lurking below the surface. These AI solutions are very complicated. They take a lot of time to become right, to gain trust and be proven in the domain. And that time requires maintenance, support, a huge amount of budget to actually keep things going. And most industries, most people outside of the tech world, many people even in the tech world, don't have a great appreciation of the size of those budgets. We're talking millions and billions of dollars for larger systems. So next slide, please. But this actually points a way towards a solution pattern. We think if we can focus the technology solutions on the areas, the very small areas that humans actually need solved, that helps us. So in the case of the analysts, they don't want a monolithic answer. They don't want the system to just spit out, go here, prosecute this person. They need to work through the information. They need to harness their expertise that they've built over decades, the proven patterns that they have for solving and addressing these problems. And by going through that process, they build trust. They build trust in the system's outputs, and they're able to add nuance and context to the data that's being produced. What we also find is if you're focusing on these human problems, you're reducing scope. And we all know in the tech industry, when you reduce scope, you can save money. You can make things smaller and faster. But there's an added benefit when it comes to advanced technology like AI. If the scope of the problem is reduced enough, the solution becomes not small, but more generalizable. We can take the AI solution and apply it in new domains. When we're trying to build something for a social good situation, often this is not a profit-motivated or purely profit-motivated decision. We are looking at global problems at the scale of, like Emily was saying, hundreds of millions of data points. But the people working on it is very small. There aren't that many people in the world that you can sell that type of solution to. So if we can focus that down, focus the actual area of the AI solution into smaller spaces, we can hopefully use that in different areas as well, which might have a different profit performance. So Richard, I think next slide, and we'll move to you.
I think you're muted, Richard.
You're muted, Richard.
Yes, I'm muted. Now I'm unmuted. Thank you. So Will already talked about the notion of having this initial problem that is very large and very costly, right? And so when you are doing this initial research, this initial technical approach, your focus is on proving it, right? And so we've got this process that we're creating from end to end that just has a lot of things happening, right? We have to collect a lot of data, and we probably are going to err on the side of collecting too much data because we don't know exactly where the signal is. So we are going to extract hundreds of different features out of that because, again, we don't know exactly where the signal is. And we have many different AI and ML models that we're putting against that, looking for different kinds of signatures that we can get out of that. And particularly within TellFinder, we're then creating a massive set of connections. We're creating a graph that connects all of those different things together. And then when the user's now working with that, we're sending a lot of data down to the user because we've got all of these different things that we've collected and processed and put together and putting in front of an expert user who is a domain expert and really understands all of this data and can really dig through that and sift through that like a detective. So maybe that gets you your initial version of the application, but there's a lot of challenges with doing that because, for instance, it costs a lot of money to try to collect all of that data and all those different data sources, all of which are changing. There's a lot of dollars also associated with maintaining and collecting all of these different features that you're pulling out of that. The models take time to develop. The models take time to run and update and keep tuning them so they're not drifting too far off course, and building this massive set of connections as that data set gets bigger and bigger, becomes more and more compute intensive, and then you're sending this large amount of data down, so you've got a bandwidth that you're consuming on there when you're pushing so much down to the user. And then finally, your user is overwhelmed because you're giving them a huge amount of things, of which some portion is actually really useful to what they're trying to do. And you're giving them a lot of superfluous things on that as well. So instead, what we need to do is turn that around and look at it from the other direction, from the user's perspective. And in reality, most users are going to be people who are overworked, right? They're like you and me. They have too much to do and they need a simple experience, right? So we don't need to have all the data. We could do some local computation to work with the pieces that they're interested in. We can send smaller sets of data down to the client so that we're not using up as much bandwidth. We don't need as many models. We can have fewer models that are focused on the specific questions, the specific signatures of things that we know work, because the users are experts and they know which ones are actually working for them and which ones are not. And when we're working with the features, we're extracting just the ones that are appropriate, and the data, yes, we would like to be able to collect all of the data, but no, we can't afford to do that. So we're going to tune that and focus that to where we've got the biggest impact in the data that we've got available. So by taking that user-focused approach, we can really narrow all the pieces in the pipeline down to meet what the user needs. Well,
right. So at Uncharted, we call this a human-in-the-loop solution. And human-in-the-loop solutions, we find, build trust. They address one of those core problems that we've identified. And really, they're doing this by breaking the problem down. You're facing a humanity scale problem. What are the pieces that the humans actually need to work on? And what pieces can we let this advanced technology do? We want to harness AI to do what it does best. We want it to take care of the data that we just can't sift through. But what we have to remember is that we need the humans to do what they do. They are able to contextualize and synthesize this data in ways that we can't expect the computers to do. And I think one critical component that kind of gets overlooked from time to time is we need humans to be passionate. We need them to be excited about solving problems. When they're doing that, when they're embedded in the solution itself, in the process of generating a solution, they get excited and they trust the output. So this process actually helps us build trust. I think we should probably move to the next slide, but I do want to say that it's almost naive for us to believe as tech developers, people in the industry, that we can come into these massive population scale global resilience problems and just apply tech and solve it all. Silver bullet. It's never going to be that simple. The humans that we have that have been working in these domains, they have solutions and we should be harnessing them. And when we take that human in the loop solution, at Uncharted, when we're combining it with advanced technology, we think of this as augmented intelligence. So it's a twist on AI, ensuring that humans are an important part of the solution, moves us forward. So can humans in the loop help AI for good? Well, I think if we look back at TellFinder, we do know that this works. And we have the hard numbers, the cost problem to look at. TellFinder as a solution, when it was coming out of research phase, was requiring maintenance costs in the order of millions of dollars. And by shifting how it was put together, how it was working, we've managed to bring it down to hundreds of thousands of dollars. Now that's an annual maintenance level. It's still a massive number, but that's one order of magnitude. That's proof enough for us that this approach of focusing on humans, focusing on the problems that they need solved, and getting the machines to do what they're good at actually works. Next slide, please. And so this presents an opportunity pattern for AI for good. We have the old world view that in corporations, in our companies, that solutions that make profit are the ones that get made. But the new reality is that consumers, everyone that we are facing with our company, they're interested in how we can actually change the world. What does interacting with our company mean? And by leaning into that, these tech problems are not just tech problems. They're actually people problems. By focusing on the humans that lets us build trust, scope the problems properly, we can reduce costs, and we can solve the trust and money problem. This lets us produce AI for good, advanced technology that has an impact in the real world. Now we're at a place where we can be producing solutions that do good, which is only going to happen if those solutions are focused on the humans themselves and not on the technology. Next slide.
And so there we are. That's our presentation. Thanks very much. I hope you enjoyed it. We covered off a very high level, the needs, the specific applications, and the challenges associated with trying to make these things actually work in the real world. Sometimes it's not the technology that's the hardest part.
Yeah, thank you very much. It was very, very, very interesting.